density. We are going to explore an important concept in physics and everyday life, density. So what is density? Density is defined as mass of a substance per unit volume. In simple words, it tells us how tightly packed the particles are inside an object or a material. Let's look at these two cubes. One is made of wood and the other is made of steel. Now here is something interesting. Both cubes are exactly the same size. They each have a volume of 1 cubic meter. That means they take up the same amount of space. But when we look at their masses, things start to look different. The wooden cube has a mass of 700 kilograms, while the steel cube has a mass of 8,000 kilograms. That's a big difference. So even though the size is the same, the steel cube is much heavier. Why? Because the particles in steel are packed much more tightly than those in wood. This is where density comes into play, and we will calculate it in the next slide. Let's now calculate the density of both cubes using the formula density equal to mass divided by volume. Let's start with the wooden cube. Mass is 700 kilogram, volume is 1 meter cube, so density is 700 divided by 1, which is 700 kilograms per cubic meter. Now for the steel cube, mass is 8,000 kilogram, volume is 1 meter cube, so density is 8,000 divided by 1, which is 8,000 kilograms per cubic meter. So what do we observe? Even though both cubes are the same size, the steel cube has a much higher density. That's why it's so much heavier. It has more matter packed into every bit of space. So this is how density works. It helps us compare different materials even when they are the same size. Let's try another example, this time with cotton and sand. Again, we are looking at equal volumes. Each material takes up 1 cubic meter. But when we check their masses, cotton has a mass of 80 kilograms, sand has a mass of 1440 kilograms. Let's plug the numbers into our density formula. Density is mass divided by volume. So density of cotton is equal to 80 divided by 1, which is 80 kilogram per meter cube, and density of sand is 1440 kilogram per meter cube. So what do we notice? Cotton is much lighter and less dense. Its particles are loosely packed and there is more air in between. Sand, on the other hand, is made of tiny grains that fit together tightly, so it has a much higher density. Even though both materials occupy the same amount of space, sand has more mass, which means it is denser. So next time you pick up a bag of cotton and a bag of sand, remember, they may have the same volume, but density tells us how much stuff is actually packed inside. Alright, let's begin with something you've probably seen before. Here we have an iron nail dropped into water. What happens? When an iron nail is dropped into water, it would sink. Let's ask why. The key idea here is density. The density of iron nail is much greater than the density of water. That means the iron nail is heavier. Iron nail is heavier for its size compared to water, so it sinks. So even though the iron nail is small, the matter inside it is tightly packed, making it dense. Because it's more dense than water, it doesn't float. It goes straight down. But now here is something that seems like a mystery. We just saw an iron nail sink, and now we have an iron ship, which is much bigger and much heavier, and guess what? The ship floats. How can that happen? It's made of iron too, right? Well, the answer lies in the design of the ship and how density works with volume. Let's look closer in the next slide. Here is a reason a huge iron ship floats while a small iron nail sinks. Okay, ship is not just a solid block of iron. It's built with a lot of hollow spaces, and those spaces are filled with air. So when we calculate the ship's density, we don't just consider the iron, we also include all that empty space inside. Let's use the formula again. Density is equal to mass divided by volume. Because the ship has a very large volume, the volume of the iron plus the volume of air, the overall density decreases. Yes, the overall density of the ship is less. Even though it's made of iron, the average density of the entire ship becomes less than the density of water, and that's why the ship floats. This is a perfect example of how shape, design and air spaces can change an object's ability to float, even if it is made of a very heavy material like iron. Let's begin with a simple way to remember the formula for density. We use this helpful triangle with three parts: mass at the top, and at the bottom we have density and volume. How does this triangle work? If you want to find density, cover the word density in the triangle. You will see density is mass divided by volume. If you want to find mass, cover mass. So mass will be equal to density multiplied by volume. And finally, if you want to find volume, cover volume, and you will get mass divided by density. This triangle is a quick and easy tool to remember all three forms of the formula. Now that we understand the formula, let's talk about units. In science, we use standard units for measurement. And when it comes to density, there are two commonly used systems: the SI unit, which is used in most of the world and in physics. It's kilogram per cubic meter. The CGS unit is centimeter gram second system, CGS, and the unit for density is gram per centimeter cube. CGS stands for centimeter gram second. So even though the two units measure the same thing, density, they use different base units for mass and volume. Let's learn how to convert between these two systems. We start with some basic conversions. 1 kilogram is 1000 grams. 1 cubic meter is 100 multiplied by 100 multiplied by 100 centimeters. So this would be 10 raised to 6 centimeter cube. You can see there would be 6 zeros here. So if we want to convert 1 kilogram per meter cube to gram per centimeter cube, we follow these steps, and finally we will get 1 kilogram per meter cube is 1 by 1000 gram per centimeter cube. Now let's do the reverse, converting from gram per centimeter cube to kilogram per meter cube. We know from earlier that 1 kilogram per meter cube is equal to 1 by 1000 gram per centimeter cube. So 1 gram per centimeter cube would be equal to, yes, 1000 kilogram per. Let's say you have a shiny golden object and you want to check if it's made of real gold. One scientific way to check is by using density. We know that the density of pure gold is 19.32 grams per cubic centimeter. So here is what we do. First we measure the mass of the object. Let's say the mass is 193 grams. Next, we submerge it in water and measure how much water is displaced. That gives us the volume of the object, which is 10 centimeter cube. So 1 ml is 1 centimeter cube. Now using our formula density equal to mass divided by volume, we would get the density equal to 19.3 grams per centimeter cube. That's almost exactly the same as pure gold's density. So based on this density, we can say that this object could be real gold. Let's try another example. This time we have a different object. Its mass is 340 grams and it displaces 20 centimeter cube of water. Okay. So mass of the object is 340 grams. The volume of water displaced is 20 milliliter, which is equal to 20 centimeter cube. Density of object is mass divided by volume, and the density is 17 gram per centimeter cube. Now remember, real gold has a density of 19.32 grams per centimeter cube. This object is quite a bit less dense than real gold. That means that this object cannot be made of pure gold. It's either fake or mixed with other lighter materials. Conclusion is, this is not real gold based on its density. Let's taste one more object. The mass is 168 grams. It displaces 10 centimeter cube of water. Using the density formula, we get the value of density equal to 16.8 grams per centimeter cube. Once again, this is much lower than gold's density of 19.32 gram per centimeter cube. So we can confidently say that this object is not gold either. This is a great example of how density helps us identify materials without even needing to cut them open or damage them. So if something is claimed to be gold, always check its density. It's one of the most reliable tests. Let's take a look at the densities of some common substances that we may encounter in everyday life. This table shows density values in 2 units, gram per centimeter cube and kilogram per meter cube, the SI unit. Let's go through a few examples. Ice has a density of 0.92 gram per centimeter cube or 920 kilogram per meter cube. This is why ice floats on water, because its density is lower than that of water. Coal varies a bit from 1.1 to 1.4 gram per centimeter cube depending on the type. That's 1100 to 1400 kilogram per meter cube. Aluminium, a light but strong metal, has a density of 2.7 gram per centimeter cube or 2700 kilogram per meter cube. Steel, much denser and heavier, ranges from 7.75 to 8.05 gram per centimeter cube, which is about 7750 to 8050 kilogram per meter cube. And copper, another common metal used in wiring and coins, has a density of between 8.3 and 9 gram per centimeter cube. So that is up to 9000 kilogram per meter cube. So what can we learn from this? Materials have very different densities, and by measuring or comparing density, we can identify substances, understand how they behave, and determine whether they will float, sink, or withstand a certain force. Let's start with a fascinating fact now. Do you know what the densest naturally occurring substance on Earth is? It's called osmium. It has a density of 22,500 kilograms per cubic meter. That means in a cube just 1 meter on each side, osmium would weigh more than 22 tons. It's a bluish white hard metal and one of the rarest elements on Earth. This shows how density can vary greatly from one material to other. Now let's learn how to calculate volume of regular solids. That's object with standard shapes like cube, cylinder, sphere. Here's a quick guide. For a rectangular block or cuboid, volume is length into breadth into height. For a cube, since all sides are equal, volume is side multiplied by side multiplied by side. For a cylinder, use this formula: pi multiplied by square of the radius multiplied by height. And for a sphere, it is 4 by 3 multiplied by pi multiplied by radius cube. The value of pi is 22 divided by 7. These formula are very useful when we calculate density, because you need both mass and volume. But what if the object doesn't have regular shape? In the previous slide we saw the objects were having regular shape. Now let's say the object is not having a regular shape. Can we calculate the density? Yes. A rock or a piece of metal with no clear edges are irregular in shape. In that case, we use the water displacement method to find the volume. Here is how it works. First, we pour water into a measuring cylinder and record the initial volume. Then we gently place irregular object into water. Water level rises. We record the final volume. The volume of the object is simply V2 minus V1. Then using a balance, we find the mass of the object. Finally, we calculate the density using the formula density is equal to mass divided by volume. So the increase in volume provides the volume of the solid. Then you just plug in this value into the formula density is equal to mass divided by volume to get the density value for this irregular solid. So let's summarize the process for measuring density of an irregular solid. Step 1, measure the initial volume before placing the object in water. Step 2, measure the final volume after the object is fully submerged. Step 3, calculate the volume of the object as V2 minus V1. Step 4, measure the mass m of the object using a balance. And step 5, plug it into the formula density is mass divided by volume. You can use this table to record your values for multiple trials. So this method is commonly used in science labs and helps us accurately find the density of any irregular object. So before we end today's session, let's quickly review the important things we learned about density. Density is the ratio of mass to volume. We use the formula density equal to mass divided by volume. This formula helps us compare how tightly packed matter is in different substances. Objects with the same volume can have different densities. Why? Because they might have different masses. A wooden cube and a steel cube of the same size will have very different densities. Steel is heavier because it's more tightly packed. Floating and sinking depend on density. If an object is denser than water, it will sink. If it's less dense than water, it will float. That's why ships float but nails sink. Then we can measure density for both regular and irregular objects. For regular shapes like cubes and cylinders, we use volume formula. For irregular shapes like rocks, we use the water displacement method to find volume. And finally, unit conversion is quite important. We learned that 1 gram per centimeter cube, 1 gram per cubic centimeter is equal to 1000 kilograms per cubic meter. This helps us when switching between CGS and SI units.